is my co-facilitator today. We're working with you on math, so if you have any question on elementary math, we are the go-to girls. We're it for the district right now. And thank you. I see a lot of people on slide 2 signing in. I appreciate that. So make sure to sign in because this is going to be your groups when we get further in. Please remember your color because that's what's going to help you. If once slide 2 fills up, go to slide 3. All right. So our goals today is we're going to be taking you through a synchronized math lesson. And we're going to be doing some old school stuff and then something a little bit new, but we're tweaking it so that giving an example of how you might be able to do it virtually. At the same time, this whole session today is really about how do we get the kids to talk? What is that productive mathematical discourse that that we could get the kids talking so that they're talking about the math and not just talking about random stuff? The other thing with that is there was a pre-reading. It was sent out through PowerSchool. I sent you an email about it. If you didn't do that pre-reading, no worries, but it is actually a very good, I'm going to say article, but it's not. It's really chapter 1 from NCTM, one of their publications called The 5 Practices for Orchestrating Productive Mathematics Discussions. So it's actually a very good article, and we're going to kind of go through that with the lesson today so that you can kind of see how the 5 elements go through. So our agenda today is we're going to do a virtual number talk. Jen has a great activity for you. Then we'll be moving into tiling a pull task, and we'll be asking you to do some individual and small group work, and then fill out what you have got your discussion on a Jamboard, and then do a brief little shout out to the 5 practices so you can kind of see how we embedded it in today's work. Today's norms, I was going to say agenda, norms is we do have the technology norms, especially in small groups. Make sure your video is on because it's very nice to be able to actually see people versus seeing a blank black screen. Also, keep muted unless you're speaking in the large group. In small group, it might be a good idea to unmute yourself the whole time so you guys can talk and share. And again, in the whole group, share questions and comments in the chat. That's Jen or I are going to be manning that as the other person is presenting. Today, we're going to be doing math. We're going to be maybe pushing your boundaries a little bit. And some of you, we may not, but others we might. So if that's the case, please be fully present, even in discomfort. Bring your fear because we all, I don't know about you guys, I love math and I still sometimes have fear coming into doing some math with my colleagues especially when I question myself sometimes. Bring that fear, but also bring that courage. And expect messiness because if we don't have that messiness, we never learn from it. And make sure to speak from your experience because we all have some experience that we can bring forth.
All right. So I've already been dropping into the chat the slide deck. So if those of you who are just joining us, make sure you go up to slide 2 and plop yourself in one of those groups because we will be breaking out off of this session. But if you have done your pre-reading, we would like you to answer this question within the chat. Based on that reading, which of the 5 practices resonated most with you? And if you did not do the reading, that's okay. Maybe just kind of looking at those verbs and those descriptors, could you put into the chat which one you're most looking forward to hearing about today? And we'll have those responses coming up here in the chat momentarily.
Jen, we have exactly 30 people here. Should I undo a yellow just in case?
Yes, please.
Okay.
All right, so I'm seeing some sequencing. We're going to be getting into that. And we were very purposeful in our planning of our lesson and how we adapted our lesson to looking at those 5 practices today. And the reading would have been on slide 1. If you want to go back to it, you would be able to do that. Sequencing, again, is sort of how are we going to be managing that tool while we're working through that. I know I was really interested in on the connecting. When we get to this connecting part, that was very interesting to me when I did that reading. I'll give you a couple more seconds to add a few more comments in the chat, and then we'll move into our number talk. All right, well, I'm not seeing anything else pop up, so let's just get right into it. All right, so Tammy's going to share something on the screen with you. I'm going to ask that you wait until I give you like the instructions on what you need to do before you go ahead and start entering anything in. But a number talk that you do through remote learning is very similar to what you would do in real life. You have a teacher that would assign an expression or a problem that they would be giving to students. This expression or problem would be something that the students would be solving mentally. And then they would also be indicating their amount of strategies that they have in order to solve that particular problem. This might have been done in traditional sense and can still be done in a virtual sense using something like a hand signal, like a thumb to indicate they have one strategy, another finger for 2 strategies, and so on, 3 strategies, 4 strategies, whatever that may be. We're going to do this a little differently. And as you might have already noticed, Tammy has entered in her initials into one of the spaces that says student, and there are a bunch of empty boxes that are going around the perimeter that say student. We would want to ask you to fill in one of those open empty spots with your initials. And this is how you're going to color code it. So you see the problem or the expression that's listed there. It's 38 times 5. And I'll let you do that in just a minute. But you need to indicate with your color in the background, do you have one strategy, which would be indicated by red? Tammy switched hers to green, so that means she has 3 strategies, but if you had 2 strategies, it would be yellow, and 3 or more strategies are going to be that green. So again, let me give you that color coding. You're gonna find that empty spot, put your initials in it, think about that problem and how you'd solve it mentally. And we want you to say 1 for red, if you have 1 strategy, at least 1, 2 for yellow, and 3 or more is going to be green. Now I will let you go ahead and think about how you would solve that problem, and I'll give you some wait time, and that's very crucial in this setting when you're doing this remotely. I know we've got about 30 spaces or so around that. We have 26 participants. I'm gonna wait for a few more to light up there, but we're gonna be starting back up here in just a second. So get those last ideas or thoughts about how you would solve this mentally. It seems to be lighting up very, very nicely. We've got our red, we've got our green, we've got New Mexico state question covered very, really nicely here. All right, so I'm gonna call for some solutions. Now, normally you do see that there is a space in the template for you to enter in solutions. And that's what I would, advise if you have students that, once you've kind of done this routine, you could be placing those solutions in there. Today, I'm just going to go ahead and fill in those solutions. And so I want to have some folks maybe just call out and let me know what were some of your solutions.
So one of my answers was 190.
Okay. And you said you had one of your answers. What was your other answer?
Well, I got 190, but I found 3 ways to find 190.
Got it. And you may have already had time to do this on your calculator and maybe possibly figure it out, but we did have somebody from our last session sort of share what could have been a possible wrong answer, and I'm going to go ahead and just enter that in there as well. She had said 55 could have been a possible answer that a student could have answered on that. And we know just as much as with students answering incorrectly, that could be a great point of discussion for our students in providing that discourse and really looking at trying to reveal what is the misconception that's behind that thought process. All right, any other solutions?
43.
43. Like that. I can see that line of thinking as well. All right. Let me give it one more shot. Any other solutions you think that might be possible solutions you or maybe students might give? All right, let's move on. So you notice that also in here is sort of a rationale. And so I'm going to ask that gentleman that had said 43. Can you tell me, how did you work that out? How did you get your answer for that?
Well, for 43, 38 plus 5. So I went 39, 40, 41, 42, 43. So I counted on.
So you did. I'm just trying to make sure that I'm recording it. And this again could be, a space for the teacher to be typing that in and for the students to be looking at like in real time. But if you don't have this, you can go old school, have a chart paper or have maybe your Promethean software up there and be recording this so the kids could see this happening in live in real time. Okay, so thank you for sharing out with that. So that is how you solved it. You just did a 38 plus 5. You went ahead and counted up from that 38, and your answer you arrived at was 43. Okay, all right. Let us hear from someone else who had a solution and who solved it a different way.
So I did the distributive property. I did 8 times 5 is 40, and 30 times 5 is 150. So 40 plus 150 is 190.
Okay, so 8 times 5, you said. So basically, what you did is you sort of broke up the products of each of the different factors that were involved. So you had the 38 originally, and you made it a 30 and an 8. And then you did the 30 times the 5, which I thought I heard you say was 150.
Yep.
And then you had 8 times 5, which is 40. And then you brought that back together as 150. You took those products of each of those and added them in together to your 190. Okay, great. So let's see, is there anyone else who thought of it in a different way?
I did 30 plus 5. I did 30 plus 30 plus 30 plus 30. I did it 5 times.
Oops. This thing is not always fun. So we're talking about repeated addition.
Repeated addition, and then.
And what was that 30 plus 30 plus 30, since you said you did it 5 times?
And then I got one. I just had a brain. Sorry.
I'm with you.
So then I got 150.
Okay.
And then I did 8 times 5.
Oh, and then you did 8 times 5. Were you just really fluent on that 8 times 5?
Yeah.
All right. So then you did that 8 times 5. And I'm just going to say, what was your 8 times 5? I almost gave you the answer.
Right. But yeah, I was just adding just a different
approach.
Yeah.
Okay. So 8 times 5, which was 40. And then again, you brought it back to that 150 plus that 40 from those 2 different repeated addition strands that you had, and that made 190.
Right.
All right. Let's call for one more rationale. Who thought of it a different way?
I did 40 times 5 and then subtracted 10.
Okay, why did you go to, can you elaborate a little bit more on that? Why 40? What was special about 40?
So 40 is just easy to multiply by 5. So
Okay.
40 times 5 is 200, and it was close to 38. So that's why I picked it. And then I knew that I added 2 extra groups of 5, which is 10. So I knew I needed to take those off at the end.
Okay, so you went to a landmark or a more friendly number, and then compensated back for that, those 2 extra 5s that you were talking about that came back in.
Correct.
Right. Lots of great strategies there. How about anyone else who thought of it differently that would like to share really quick before we finish off? Oh, thank you, Tammy.
Sure, I did 3 times 5 and then multiplied that answer by 10 and then the 8 times 5 and added them together.
Okay, so the 3 times 5, was that the 3 being the 30, or is that?
Yeah, so I just did the 3 instead of 30. I thought 3 times 5, but then I knew because I divided the 30 by 10, I needed to multiply that answer by 10. And then the 8 times 5
Okay,
and added
so
them together.
would you like me to go ahead and record that? I can record that in the chat how you did. But what you were talking about was breaking that factor, since you knew that 30 had a factor of a 10 and a 3. You did it by the 10 first, and then you like tripled it. I think that's what you said. But it sounds like you broke that into the factor, and I probably got that all wrong. I wish I could like have captured that a little bit better. All right. There is some other ones that in case you had not done it, maybe you did double and half, and 38 is a really good example. 38 times 5 is a great idea of how to think about double and halving. You could have doubled that 5 to make it a 10, I think similarly to what you were saying, and then you could half that 38 or 19 and then do 19 times 10. And we also had a gentleman on the earlier session that had said that they might have done it perhaps by an area model. So those are all different ways that you could have it. This is just a template that could really surface and evidence some of the ways that the students might be thinking about how they did that problem. Do you have any questions about the template before we move on to our next set of a task?
So can we get a copy of that template, or do we just need to go and copy it out of the slide deck that you shared with us?
It will actually be shared with you down at the very bottom. We have a resource page, and it is in that resource page under the Number Talk template. So we will be getting to that here shortly. All right, I'm gonna let Tammy take it over.
All right, everyone. So we're going to be moving into a math task now. What I'd like you guys to do is go ahead and mute yourself on this one. Click on the link that says here, launch video. We've been having a lot of technical issues today. So just go ahead and launch it. It's a 1-minute little intro video on it. And I'll be quiet for a minute, watch it, be back here at 1:07. Have most of you been able to watch that? Okay, I'm looking for head nods. Okay, cool. All right, so this is a oldie but goodie activity that I love, 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 love. It's tiling pools. And what you're going to be doing is, let me move actually to the next slide, is there is a lab sheet. Normally I would give you this lab sheet and hand it out to you, but since we don't have that option, you're going to need paper and pencil to do this. I'm going to pop over to another tab so you can kind of see what it is. And it's the tiling pools problem. And it's Custom Pool Company, as the nasally people said, that they're trying to figure out for any side, how many tiles will they need. So to get you started, we have a 3x3 pool. And without counting, because we're wanting you to start recognizing that pattern in there. How many tiles do you think it will be? Then we go to a 5x5 pool, and then we go to a 10x10 pool. After that, this is where the pattern comes in, and you can test and check with any of them, with any of those examples. We'd like you to come up with an expression for a generalized any size square pool. How could we figure out how many border tiles? I want you to focus on the expression, and if there is time, if you would draw a representation of what that would look like. It's actually, with our debrief, it's really cool when we can see a picture and you guys can explain on that. Then here's what you're going to be doing in small groups. Once you first get there, introduce yourself and just say where you're from, what school. Then we'll need you to pick a facilitator that will help move along the questions and the discussion. You'll need a scribe. That's someone who's going to get in that Jamboard and actually type up what's going on. You'll need, the scribe might want to also project for your small groups, if that's the case. You will need a timekeeper. I will tell you when to come back, and that timekeeper does need to remind you 1 minute, let's stop and move back to the main group. And then also a presenter, because when you come back, we're actually, Jen and I are going to ask people to each group to speak out. And I'll like pull up and say, yellow group, what were you guys talking about? So you will need a presenter, so have one person that will do that. But before you start all that hard work, we want to give you this individual time. This is where we're going to adapting the Kagan strategy called consensus placemat. And what it is we don't have a beautiful placemat in front of us, but we want to give you that individual time. Then you'll share out your responses with each other and to come to consensus on that expression. If there's time, do a representation, and then presenter be ready to share out when you come back. This is what the Jamboard will look like. I do want to point out with Jamboards, I can't put links in there, hide links very easily. So this main meet right here, this teal color thing, this is actually the meet back to this group. So when you go to your small groups, you can actually close this group so you don't hear us talking in the background. And then you can go to your small groups and then come back here. The link to the Jamboard is here if you'd like to get to that. I'm going to pop over there so you can see what exactly it looks like. You'll notice your group colors are here. So look for your group color. Make sure you're on the right slide. All right, that moves us into I had asked you to remember your color. If not, just scroll up back to slide 2 or 3. Your link is here. It's also on that other slides. Go to your breakout rooms and make sure that you guys are having some fun with some math today.
And let us know if there's any problems with getting the tools up and running. We had shared some permissions earlier, and sometimes internet as it is or faulty, whatever, we just make sure you can manipulate and do what you need to do in the Jamboard.
Be back at 1:20.
So we should be coming back into the meet here. Should be wandering back into the main meet.
I'm back.
Give them a few more.
Let's give the red group one more minute.
Okay.
I'm hoping that some of them will rejoin us really soon, because I really, really enjoyed their productive struggle.
They did. They had quite a bit of it. Don't forget to leave me some time at the end, Tammy.
We'll have to.
It's okay. I'll go quick. You know, I can speak fast. These folks might be willing to stay a few extra minutes with us.
Will
All
you
right.
share our jam boards for us as we share out? Is that something you guys will
That's
do?
exactly what my plan is. I'm going to have the Jamboard up, sharing, so you guys can talk about it. All right. Before we start with that, of course, I'm getting spam on my phone. I wanted to just quickly go over the 5 practices that we talked about today. And with this one, just letting you guys know, the first thing I did was I picked the problem and then anticipated all the answers that you guys could come up with. So if giving you an idea, like I have ended up coming up with like 8 different answers that I thought you guys could come up with. Now, to be honest, in my very first group, they came up with one I never even thought of. So it's really cool. I like that. What Jen and I did today on step 2 was monitoring. You'll notice we popped in and out of the groups. Sometimes we didn't say a word. We just sat and listened. And other times we might have just answered a question or helped move your thinking a little bit more, but that's all we did with monitoring. 3, selecting. This is the critical step. This is the one that you got to pick which groups you want to present. We ended up only having 3 groups, so hopefully I'll be able to get most of you to be able to present. But I do have certain ones that I want to for sure hit. Then from there, after you guys, I made little sticky notes all over the place. I have what I then put what order I want you guys to come in, and that's where my sequencing part. The last one is the connect. This is where we're connecting the math and as groups and talking about it. So hopefully today's all about expressions. So hopefully we'll have some connection in the math about expressions. So that being said, I am moving to red group. I'm hoping someone's here. Is someone here from red group? They may still be working on it. Oh no, there you are. Okay, Kelly,
Go ahead, Linda. Sure.
Can you guys explain really? I wanted you guys to your productive struggle of how you didn't come up with this right away. What you guys came up with was really numbers and using numbers for it. Can you talk more about that, please?
Right. And so before I came up with the expression, I was really looking at patterns and these types. I teach my kids to kind of look at types of questions, types of math. And to me, anytime you're dealing with tiles or something that's kind of repetitive, is there a pattern there you could look at? So I was first looking at the pattern. The pole, originally, the pole size was a 3x3. And then I looked at the dimensions with the length on the top and bottom length is both a 5, but the width stayed the same. And so, or the left and right, those dimensions stayed the same. So then I moved on to the next one, and that was true with the next one. You have a 5x5 pool. It increased by 2 on the top and bottom, but the sides stayed the same. And then the 10x10, since they were odd numbers in a pattern, I came up with a formula or an expression, and then I checked to see, is that going to be true for an even numbered pool, which would be the 10x10, the sides stayed the same, and then again, it increased by 2. So assigning that, kind of just really focusing on patterns. And then I looked at the pool size. So I added the pool size, one dimension of the pool size plus 2, And since there's 2, then we multiplied that by 2, and then increased the top and bottom by 2, and that gave us the total. And it was true for each one. So I just substituted the values and then actually solved it. And it appears that that expression could work for any pool size. So I think that's kind of looking at the type of problem. It was to me more of like a pattern, trying to identify, is there a pattern in this problem without getting overwhelmed and trying to think of, dimensions and too many other things. But that was my approach.
Okay, thank you. Wow, you guys have added a lot more, Green Group, since the last time I saw you. All right, so go ahead and talk us through your M1. That's the one that I was really looking at.
Well, I think the person who had the M actually had to leave. She had students, so I'll see if I can kind of capture what she was saying.
Sure, or you can talk about something else. That's fine.
No, that's fine. So she was labeling the top and bottom as M, and then the 2 sides would be M minus 2. And so then we were talking about, well, how did you get M? Because the expression says that the side of the pool is S. So then we said, well, we had to identify what M was. So M is equal to S2. So then you could do the top and bottom as 2M, and then the 2 sides would be 2 of M minus 2, which is basically just S.
Okay, thank you. And I want you all to be thinking, because my question is going to be, how are all of these different expressions, the parts related to back to the problem? So be thinking about that, because there's this one has a subtraction in it. The first one had addition in it. But our last group, the purple group, did it differently. So purple group, can you walk us through how you thought of this?
Sure thing. You used that teacher voice when you said differently. That makes me hesitate. But so we came up with an incorrect expression at first. We were using s plus 1 squared, which worked for the 3x3 pool, but it did not work for a 5x5 pool. So then one of our partners decided to draw on the pool itself, and we thought that would be something that our students would be to draw these out. And so then we came up with the donut strategy, so or the picture frame, where we're going to call S the number of tiles on the side all the way, and then from top to bottom subtract and square it, and then go S minus 2 and square it, and we would get the correct answer. So we filled in a few of those into our T-chart, and the problems worked out. So we tried the 3x3 pool, and we tried several others, and the number of tiles worked out for us. Okay. But we did not take pictures. We were trying to draw things directly on using the editing tools on the program. So it takes longer than doing it in person.
I like the use of how you connected those parts of that expression, like the idea of the S being all the way around and the S minus 2 being sort of the inside or the donut hole that you talked about. So you connected those parts back into the expression that you created.
Yes, my math teacher is probably cringing at my explanation, but still, he is my dad, so he'll give me a break.
So you guys have had several expressions now that you've looked at. How are they all related? How are they similar? Sorry, I have a cat that will not give up for anything.
Called a cat bomb. I have it too. Mine comes up.
So
I can make a basic observation. Would that work?
Sure, of course.
Absolutely.
Okay. Cool. So all of them, or none of them, are simplistic. So when you first, at least my brain, when I first hear the problem, I think, oh, it's just a simple problem of one number times another equals the answer. And for all of them, it describes a whole lot more than just that. So it's not just a basic, simple math problem.
And not just thinking about its patterns. It could be connecting that idea of area and perimeter, perchance, in the way that you're looking at it. There could be multiple different entry points and layers and ways that you could come in and across to come up with whatever expression or representation, as we saw in this last one, how you can explain how your thinking is happening.
And giving you guys a heads up, this was the area model. Purple group did the area model. The others did a perimeter model. So just giving you a heads up that you're going there.
All right, we've got about 4 more minutes, Tammy, so I gotta like run through this real quick.
Oh my gosh.
We're good. I'm quick at this. So this level, or this particular slide, we were talking about maybe pulling back the curtain in the way that we adapted our instruction today with you, and as well as how we adapted our planning, and thinking about how are we going to be purposeful and getting you to talk and have discussions amongst each other. So I'm not going to sit there and read each of the bulleted lists of things, but basically we tried to make it so that you had multiple opportunities to participate, whether that be in the slide or the chats. We want to make, varying groups of either individual time for you guys to think, group time, and then small group time to kind of cajole your ideals and things together. We wanted to make sure we put some structures in there, like a Jamboard, for you to be able to collaborate interactively with and among each other. We thought purposely about the math that we offered. I know there was a group that was like, I don't like this expression. We wanted you to come with that fear and that courage, and we thank you for having that fear and that courage, because our students struggle, and that productive struggle is part of learning and understanding the math. And it is, as you can see, it's a lot easier lift when you have others that are around you that are kind of struggling and working on trying to get to that consensus about an idea. So we were very purposeful in that. The very last thing that is on there is we are providing you, and you're going to go to it next, that's perfect, some resources for you to do this with your students. We've listed some asynchronous and some synchronous ones. The synchronous ones I'm going to highlight are going to be more lend itself to that productive struggle and those productive mathematical discussions or discourse conversations. That number talk template is that second one, that one that we did earlier. There are also there's a math talk slides, math talks for slides. It gives you ideas in there for like doing which one doesn't belong, that you can do on a template interactively with kids, where they can like mark, which ones they don't belong. And then you could, call on them to give them your rationale, similar to what we did in the number talk. There's 3-act tasks, which provide you like an idea of a hook. And then you kind of give them a hook, ask them what they notice and what they wonder. And then you'll bring them back, give them what information they know, and then they can work collaboratively in groups to kind of come to a solution, and then you bring it all back together in this sort of summary connecting idea. And we just wanted to give you some like other resources so that you can kind of start thinking about how you would use or adapt your instruction, which leads us to our next question. And hopefully we have some time for you guys to answer this, because I do want to hear what you think. When you've participated in this session, can you now think of some ways to adapt your instruction to be able to provide more opportunities for your students for mathematical discourse? If you can think of some of the ways that you can adapt that instruction, could you please plop that into the chat for us to look at? Or feel free to unmute. Because I know I'd be typing furious.
Well, Jennifer, I'll just turn my camera on. I really liked the collaborative board. I really liked that slide. And that's just one way to really focus the class's attention on the problem. And so just being able to have that little bit of ownership on that square, and then allowing for, those, so that kids could visually see there are multiple ways to solve math problems. There's not only one right way. So I really like that was great. The whole collaborative piece, and sometimes it's really hard to visualize. And when we're creating our own slides, how do you do something like that? So that's a really nice piece to take away with.
Oh, awesome. Thank you. I'm glad you guys like that. And then I also see Amy's mentioned that there's a lot of teachers use the Jamboards independently. And it was fun to see how that worked within that collaboration setting. So maybe another tool you'll have in your tool belt when you're working and thinking about how you can do that. And those were some of our considerations, and thinking about, like, how would we get students to talk to students? How could we chime in with those 5 practices you saw us pop into your meets? How could we be monitoring and also listening? And, but that anticipating, we had to anticipate what might have been happening or misconceptions might be happening in those conversations. So great suggestions, and hopefully you'll leave a little bit with something that you can use again tomorrow. We're going to leave it open for some lingering questions. We'll stay on here for just a little bit if you have some questions, but we want to make sure that you guys go in and take that survey, and that will be, and then all of the resources, this PowerPoint will be available through that bit.ly site, that bit.ly, bit.ly TLF Summit. And make sure you take that survey and just let us know what other kinds of sessions you might be looking to have in the future. Again, we'll stay on here for just a few minutes, but we thank you for allowing us to share with you that synchronous lesson today. And if you have any lingering questions, please ask. We're here.
I have one. My name's Deborah Blea. I'm sorry to, earlier I was in the middle of our meeting and my computer crashed, and yes, it was. And then I always, like, when people say that during our PDs, I'm like, yeah, right. And it happened to me. Anyway, my tech got us back on. Will you have access to the I wanted to hear the discussion. And it was, like, really good, because the active struggle is what really just.
Though we won't have access to the small group discussion since we were recording that, but you'll hear the whole group discussion. We did record it. It will be posted on our, I'm going to say Google site, but the CNI website that we keep sending you a link to.